All right, everybody, welcome to another webinar from Robotics. My name is Kim Wilkins. I'm a co-founder and CEO of the company.
My name is Sona Tommy. I am the media coordinator here at Reversa.
And so this time we kind of want to box of robotics itself. And as you notice, we're sharing all the resources, so you should be able to get access to everything we're doing here. You're here with us live or watching online later, welcome. We're really glad to have you.
Okay, so actually makes something a robot. So at the end of this, what is and what is not a robot, we'll be able to break a robot. And then you should also have an idea about how to help students design, explain, and debug their robot behavior.
Awesome.
Quick little warm up. I kind of just want you to blurt out what you think. Tell me, is it a robot or not? Ready?
Okay. All right. Do you want me to explain why I thought so, or just tell you?
Yeah.
Okay.
Let's do a little explanation too, and maybe I can add in my thoughts.
Okay. A toaster. Gut says no. And
No.
mostly because it's not, we're operating it and it's not thinking on its own.
I agree.
But maybe there are some that do.
Yeah, I feel like there's. Okay.
Remember, that was sort of available to anybody.
Right, and it can jump into other things. I would call it a robot.
Yep. Human, because I feel like, this remote controlling of something by a human means it's not a robot, but it has a lot of other features of a robot. It to not run into stuff. So I'm mixed on this one. Maybe it is, maybe it isn't.
I'm gonna say it's not a robot just because it's human control instructions.
Yeah.
So for those reasons, I'm gonna just.
All right.
Okay. Factory robot arm.
Yes. So I think this is a title, but of course that doesn't always necessarily mean it. But most of these are automated. They're doing things that have been programmed for them to do to create whatever it is they're creating.
I think I agree. Yeah, I would say a factory robot arm is a robot, and I like your explanation for it. Okay, a vending machine.
Okay. Gosh, I would say that traditionally, no, but like we have such advanced vending machines here now that are doing a lot of things. So maybe I guess, yeah, I still feel like I'm coding stuff in. I don't know. This one I'm unsure. Mostly no.
I'm also mixed feelings on this one. I feel like yes, it is programmed to act a certain way, and it kind of takes input when the person that wants something puts what they want in. Yeah, I think it has the characteristics of a robot, but I just don't see it that way. So this one's we'll put that in the gray space. How about
that? I'm wondering if there's some that can like actually send out a message when they're running low on things. That becomes more like they're based on a condition, they're doing something, right? So yeah.
Okay, cool. Next, we have the remote controlled car.
All right. Well, this one again, because it's a human operating it, that feels less like a robot. And yeah.
Yeah, I agree. I think there are robotic elements to it, but just the remote controlled is making me say not a robot.
Yep.
And
Reversa, yay! Well, yes, we hope we're a robot. There are some elements, like when we're in a standalone, the coding that's happening is with the buttons, pressing the buttons, and that's sort of like pressing on the vending machine. So, it's not as robot-y as when you're actually creating code around it to make decisions on its own autonomously.
Right, totally agree. A
smart thermostat. Okay. Because oftentimes you think of robots moving or something moving with them, and this doesn't move, but I guess it could make a sound. And it's definitely got programming in it. So I'm on the fence on this one.
I would say I'm kind of leaning towards it is a robot just because I know it can sense the environment that it's
Mhm.
in. Even though it isn't moving, the environment still impacts it and it responds in a way. Um, and it does have that programming aspect of it and is able to act a certain way. So I see why you're in the gray space. I think I'm going to lean for this one
And there
though.
also is a display, so that's definitely another output there. So
Right.
yeah, okay, maybe you've convinced me.
Really? Okay. Okay. Cool.
Chatbot. Okay, that's interesting. I feel like a chatbot in and of it, like if you're doing it at a computer, it's not a
Uh
robot.
huh.
It does have the programming. It is responding to what you're doing, but it doesn't have sense. It's not sensing its environment.
Right, right. I kind of agree because the bot part is kind of throwing me off. I'm thinking that
Mm-hmm.
it's a robot,
Yeah.
but I also like I don't see it sensing the environment and like responding to it. It is giving output, but it isn't responding to the
Right.
environment.
Right.
So, okay. All right, that kind of wraps up our little rapid fire activity to warm us up. And let's talk about what patterns we noticed. I feel like for us to agree on certain things, I think it was kind of like, was it sensing an environment? Was it like
Mm-hmm.
having an interaction with it?
Yep.
Um, the parts where we kind of disagreed on, it was kind of just like what, like the body of a
Right.
robot.
Does it have to move?
Right.
Is
Yeah.
that part of a robot? Does it when it's thinking, the thinking part, is that autonomous or is
Hmm.
that humans still having some intervention?
Right.
Yeah.
Yeah. I think like the image of it also kind of sparked debate of like, oh, does it look like a robot or does it just have the characteristics of a robot? Um, but yeah, I think like when we decided, we kind of just decided on whatever characteristics
Mm-hmm.
a robot had.
And
I don't
there's
know if
some, I
you.
think, almost bias,
Yeah.
because we already have an idea in our head of what a robot is. And so when it doesn't look exactly like what our preconceived notions are, that can sort of trip us up as
Right.
well.
Totally agree. Okay. So this kind of leads us to a simple definition of kind of where our thoughts are leading us about what a robot is. And just to put it out there as it is, a robot is something that can sense the world, think with code, and act by moving or changing something all by itself. And that last little part, all by itself, just to delve a little deeper into that about why we think it matters, is because a robot that can only sense things simply just collects data. And then a robot that only thinks can't really affect change. And then if the robot can only act, it just simply follows commands. It isn't
Mm-hmm.
really getting an input and thinking based on that. So we kind of just have to think about robots as systems. It's when all these parts, the sense, thinking, and acting intersect and make something that can do something special, just like a reverse robot.
Right. And I think, this points out that robotics is changing.
Mhm.
It's technology, so it's changing quite rapidly and things are advancing. And so it's not just us that don't always agree on what makes a robot a robot. Roboticists who are working on this also have varying definitions and varying whatever. But these are three elements that most people that work with robots would agree about.
Yep. Yeah. Okay, great. We're gonna do another activity just to kind of keep us going with exploring what a robot is, and this is a robot sorting activity. So how this is gonna work is just to brief what the parts of a robot are. The parts of the robot will either allow it to sense the environment, it will allow it to think, so take what's in the environment and process that. And then there are parts that will also help the robot to act, so to do some sort of action based on what it has thought about. So for the next images that you'll see, I want you, Kim, to tell me if you think it's a sensing tool, a thinking part, or an acting part of the robot.
Okay. All right, so
Buttons.
buttons. So this is putting something in. So that to me is sensing. It's sensing whether a button has been pressed.
Perfect. That's right. Next up we have a light
Light
sensor,
sensor, well, that handily has a name in it. So it's sensing whether there's light or not. So that's a sensor, sensing.
right? And also, if you guys want to follow along in the chat by responding your own thoughts, we can get that interaction going as well. All right.
A motor. So a motor is doing something. So to me, that's acting.
Okay. Yep, that's right. Camera.
A camera. So I think this one might be a little tricky because a camera could be sensing you, but it also could be acting in its recording. So where did you put it?
I was leaning towards sensing because
Mhm.
usually a camera would be the purpose of that would be to sense, but totally valid thought about how it also acts because there is an action involved with how that sensor is programmed.
Right, and
So,
especially ones like we have this fancy one now that we're using that can actually, if we set it up, would track us and
yeah.
stuff and move. So yeah.
Okay, so great. We'll do a split on this one, even though the circle is just on us.
All right, so
Code
code.
block.
So this to me is the thinking part, like, and especially you have the example you have here is a conditional. If
Mhm.
this statement is true, if this thing is happening, then do something, then make something happen. So that to me is thinking.
That's right.
Yay!
And these code blocks come right out of MakeCode, which is our main integration tool for coding with Roversa. It's a really great tool, and I totally recommend testing it out with your Roversa robot. Next up, we have a wheel.
A wheel. Okay, so it's not sensing, it's not thinking. So it's turning, it's making something happen, it's acting.
Yep. Great.
So microcontroller. This is a microbit from the BBC, and it's the brains. Happens to be the brains of Reversa, and so I know it's doing the thinking part. It's the thing that's making decisions and deciding whether the wheels turn or whether these LEDs come on.
Spot on. The thinking tool. How about the LED light?
So the LED lights are something coming out of this. They turn on, and so that's output, and so that's acting.
Ma'am. Okay. Now just to expand our knowledge a little bit, now that we've kind of looked at the different parts, whether they help the robot sense, think, or act, that kind of leads us into like a broader, just a step out into computing devices in general.
Right. And so computing devices are something that have been part of standards for a while now. And again, more computing, like as technology advances, more things get dumped into the computing devices category, right? And so the definitions for these are often expanding as well. So, computers, mobile phones, robots, microchips, appliances with microchips inside them, cars, like, even non-automated cars have a lot of sensors built in.
Right.
So that's all computing devices.
Yep.
And just like we have robots have this definition of sensing, thinking, acting, computing devices also have similar things. So there's input, whether that's typing on a keyboard or doing your mouse or hitting the buttons on Reversa or talking into a microphone, anything that's going in to computing devices regarded as input. And then we have what comes out. So there's output from that. So again, whether it's the pixels lighting up on the screen or sound coming out of a speaker, or in the case of Reversa, wheels turning, that's all something that's output. It's also related to action.
Right.
And then this is related to the thinking part, the CPU, the central processing unit. So all computing devices have some sort of way to process the information that it's sensing from the environment and some sort of coding that's happening that's making that happen. So, one of the things when we talk about computers having brains and talking about them thinking, we still have to remember it's humans that are coding that stuff to happen.
Yeah.
So, yeah.
Okay, so robots are computing devices, and so is our Roversa robot. So just to go into a little game on exploring the different parts of the Roversa robot itself and like relating that to the parts of a computing device, I kind of have the different parts of.
I'm going to stop sharing now so we can see us full screen.
Okay, so the QR code on the slide that you guys just saw will take you to where you can access these worksheets to actually print the Build a Bot game out yourself and use it unplugged in your classrooms. Just to go over the different parts of the game. We have the computer, the CPU.
So for us, that's the microbit.
And then we have a power
Supply.
battery.
And then you plug in our power supply here at the back.
And then there is the output, which is LED lights, which also show when.
So there is one at the back, and then I don't know if you'll see it on here. It's a smiley face on the LEDs here.
Okay, great. And then we also have the wheels, which are an output. The inputs, which are the buttons. And then the body of the robot is what's connecting all these parts together and making it a computing device.
Yep. And then the thing that's not part of this that I also want to mention is we have the buttons for input, but because we're using the microbit, there's also sensors on it. So you can do some sensing with this as well.
Mm-hmm. Okay, so just to go back to our game now, Kim, do you want to explain how this will work?
Yeah, so the idea behind this game is that you get a set of 4 students together, and they each pick a number between 1 and 4 that they're going to beat. So each of these numbers represents a student, right? And the game they're going to play is who can be the first to build their robot. And so in order to do that, they have to roll a die, and whatever comes up, then that they get to check it off. So let's see, what's the.
Okay, so here's your worksheet.
Here's mine. Okay.
And here's mine. We'll have our answers come up on the screen as we roll. Okay, I'll be person A and you can be person B.
All right.
I'll roll first. Okay, it looks like I got a 1. Here we go. So I'm going to put a check mark on the 1 box. And then
so you have the CPU.
Yep.
Okay, so I'm going to do mine. And I've got a 4.
Okay.
So I get wheels and motor. Oh, we didn't mention motor as well. So, that's the actual thing that's making the wheel go.
Okay. I got a 3. So now I'm going to check that part off.
So you've got your LEDs. Excellent. Why didn't it go forward? Oh, there we go.
You got 5.
I got 5. Okay. Great.
Okay. Oh, wait, no, you got a 4 again.
Oh, that's a problem. So I can't. So yeah, if you get the same number, you don't get to get another one. So I don't get to add.
Right,
anything.
And I just rolled a 5. So
oh, dang, you're ahead now. Okay. Roll again. Okay.
You got another 4.
Oh, what?
That's a skip. Okay, and then I got a 4.
Oh, looks like you're gonna beat me. 6.
Okay. Okay. I got mine checked off as a 6.
Okay.
And then.
All right. It really looks like I'm not gonna do well here.
And then I rolled a 2.
Oh my gosh.
Okay.
Very nice. So you won.
Okay, wonderful.
So the idea here is, as they're playing this game, they can, recognize these parts, and it's just kind of a fun way to get that into their brain.
Okay. So we have another activity that kind of goes along with the same idea, and this one's a Be the Bot game. Again, all the activities and resources can be accessed at this QR code. And Kim, if you want to walk us through how we're doing this one.
Yeah, so the idea behind this one is that, again, this is another unplugged activity. And these are great ways to make connections with robotics without having to be on a screen. And so they're going to be the robot. The students are going to be the robot. And before they do that, they're going to come up with some dance moves that, if they rolled a 1, what are they going to do? If they rolled a 2, what are they going to do? 3, 4, 5, 6, so on. So sort of come up with the rules for each roll of the dice. And then they're going to start playing with that. So, the first time they might roll 1 dice and say, okay, 6. And
whatever the rule
for is, then the other person has to do that. And then maybe they'll add 2 dice and see bring things together. And eventually you can kind of see if they can do it from memory as well, and see how many dice they can string together of moves.
Okay, great. So I think we should just make up some quick rules and try it out real quick.
Okay.
Okay, so I'm going to put 1 means clap once.
Okay.
Do you want to?
Tap the table twice.
Okay. I'm going to say 3 means raise one hand.
Snap fingers.
5, I'm going to put in touch your nose.
Beep.
Okay, perfect. Now let's test this out. I can roll the dice, and do you want to be the robot, Kim?
Sure.
Okay, perfect.
So
I just rolled a 6.
Oh, I shouldn't even say. That could be another thing you do.
Right. So like I'm completely controlling you by what I'm rolling.
Beep.
That's once. I rolled a 2, which is tap the table twice. I rolled a 1, which is I get to clap once. I rolled a 3, which is raise my hand. Okay, perfect.
So you could have somebody who's the controller, somebody who's a robot, and then like a third person not having access to the rules, and trying to guess what the rule was based on what was rolled.
Oh, right. Yes. Yeah. That's a great way to do it and use it in the classroom as well.
Yeah. And then you could do, I'm going to make you do it now. So I'm going to make you do 2 dice.
Okay, cool.
All right. So 2, 3.
2, 3.
Okay. 2, 4. There we go. And on and on.
I had to catch on to that.
Yeah.
I needed that little reminder.
Yeah. Yeah. So that's that. Again, just a fun way to talk about how rules, how computing devices need rules in order to think, and then you are the ones who are creating that, and then how you can string them together to do different things.
Right. And just to like think about how the process that went on in our brains as we kind of went through this was, especially like for me, when you introduced that new rule, I feel like I had a bit of like a stump getting used to it.
Right.
So that's normal for when you're programming and like robots. And if there is that initial error, you just troubleshoot, program again, fix the issue, and then try it again. It works. So that's like a great tool, I feel like, thinking through that process, and also even like working through creating the rules of like how programming works. Like you need to give the robot instructions for it to do something,
and you need to be specific.
Very
like we should have maybe created some rules that neither of us understood, and then we'd have to debug those.
Yes. Yeah. So I think this process really like helped me think about from both the programmer side and the robot, even though the robot doesn't have a brain, but like from an action point of view.
Yeah. Cool.
Okay, so our last kind of activity to really expose like anyone to robotics is to help them or give them the chance to be an engineer themselves. So our little activity here is to create a foldable, which should look like this, where you can design a robot assistant for a classroom problem. Okay, so to create an engineer's manual foldable, I'm just going to walk you through the process, and you guys can do this on your own time. We're not going to really do all the steps together. But what I did was I started by taking a blank sheet of paper like this, folding it, and then cutting 3 strips down just on one of the flaps. So it should end up looking like a manual where I can just flap each little pocket. And then once I have the setup, I'm going to write in the 3 parts. So the first flap would be what my robot senses. The second part would be a rule, which would be in the form of an if-then statement. You would put the if on the front part and the then on the back part. The third flap would have what the action would be that your robot would do. And then the fourth flap would reveal a blueprint drawing of your robot. So we have a little example here.
I think we need to stop Cheyenne so they can see it.
Okay, so this is my classroom robot that I designed to help when the noise levels get too loud. So this first flap says my robot senses noise levels in the classroom. The second part says if my class is getting too loud. The then says the robot turns the red light on. And then for my action, I have it acts by turning a red light on. And then the blueprint drawing of my robot looks like this.
Awesome.
This is a great activity you could have for your classroom to get your students excited about solving their own classroom problems using robotics.
Cool. Thank you.
Okay. All right, so let's just do a big takeaway on what makes something a robot. Just to go back to our simple definition, it's a system that senses, thinks with code, and acts all by itself. It isn't really how fancy a robot looks or the outward appearance that should define it, but it's the simple rules, the clear inputs, and then the learning that comes out of that robot. So when students get a chance to design their own robots, they are really learning because they're thinking about the logic that goes into building a robot, the cause and effect that you use to program it, and then the whole system's thinking of it's a body that has all these parts and everything needs to be controlled. So yeah. And then Kim, if you want to talk about.
Yeah, why this works in the classroom. I think that robotics is fun. It can always just be a fun thing to do, and so that's very high for student engagement. And you can take advantage of that to then sneak in. Here's what's really happening. With computer science, I think my passion is letting kids and teachers see under the hood of what's happening. Why is this working? Because it can also often seem like magic, right?
Yeah.
Especially advanced robotics and the stuff happening in AI. It just all seems like, wow, how is this happening? And so these are really activities to kind of lift the cover and see, oh, okay, it's it's very basic, it's pretty basic stuff. And the complexity comes when more and more layers are added upon it. So we're trying to break it down into its most simplest form so that then we can build on top of that, and kids can build their knowledge on top of that.
Right. And all these activities are great for you to take back to your classroom. You don't necessarily need a reverser robot to do it, as you could do it unplugged. The Be the Bot is a great warm up to get your class thinking. Even the Robot Assistant Design Challenge would be a great intro to robotics activity, or even a CS integration activity if you want to add in some programming with it. Yeah, just start with one sensor, one action, one rule. Keep the constraints small, and then see what your students can do.
So again, thank you so much for joining us. We would love to have you join our Reversa community, which is on a platform called Circle, where we're sharing lessons and these webinars and professional learning opportunities and things like that. And we are doing pre-orders now for Reversa. So that is sort of where we are in the process as a new company. So we're very excited to be able to offer that. And so that's available too. If you'd like to speak with us, please reach out. I'm Kim at reversa.com and be happy to talk with you. We also have a bunch of classroom materials like mats and whole activities around different areas that are ready to go now. You could have them now, that Sona has helped design with teachers. So they've been teacher-driven lessons that we've sort of wrapped your magic design around. Yes. So those are also ready to go. So we'd love to have you join us, try things out, give us feedback, and wish you all the luck on introducing robotics to your students.
Yep. Thank you all so much.
Bye.
Bye.